Writing: imagine standing on a runway in the middle of the Cold War and watching an aircraft so advanced that even today it looks like it belongs in the future. As the sun reflects off its massive white body and enormous delta wing, 6 powerful jet engines roar to life. The ground trembles beneath your feet. Moments later, the aircraft accelerates down the runway, lifting into the sky with incredible grace before climbing toward the edge of space. This was the XB-70 Valkyrie, one of the most ambitious aircraft ever built by the United States, a machine that pushed the limits of speed, technology, and engineering in ways few aircraft have ever matched. The story of the XB-70 Valkyrie begins during one of the most intense periods in world history. The Cold War was at its peak, and the United States and the Soviet Union were locked in a competition that extended from military power to scientific achievement. Strategic bombers were a critical part of national defense because they provided the ability to deliver nuclear weapons across vast distances. The U.S. Air Force wanted a bomber that could fly higher and faster than anything the Soviet Union could intercept. Engineers were given an extraordinary challenge: create an aircraft capable of cruising at more than 3 times the speed of sound while carrying a heavy nuclear payload over intercontinental distances. At first glance, the mission sounded nearly impossible. Flying at Mach 3 for extended periods created enormous technical problems. Air friction generated tremendous heat, enough to weaken conventional aircraft materials. Engines needed to operate efficiently under extreme conditions, and the airframe had to remain stable while traveling faster than a rifle bullet. Yet American engineers embraced the challenge with determination and innovation. North American Aviation won the contract and began developing what would become the XB-70 Valkyrie. The aircraft's appearance alone was revolutionary. Instead of a traditional wing design, it featured a huge delta wing stretching across an enormous airframe. Its sleek, futuristic shape was carefully crafted to minimize drag while maximizing stability at high speed. Every line and curve served a specific purpose, making the Valkyrie one of the most recognizable aircraft ever created. One of the most remarkable innovations was the aircraft's compression lift technology. Engineers discovered that the shock waves generated at supersonic speeds could actually be used to improve lift. The Valkyrie's distinctive wingtips could fold downward during high-speed flight, allowing the aircraft to ride its own shock wave. This concept increased aerodynamic efficiency and stability, helping the bomber maintain Mach 3 performance. Even decades later, aviation experts continue to admire the brilliance of this design. The size of the XB-70 was breathtaking. The aircraft stretched over 185 feet in length and had a wingspan of more than 105 feet. Despite its enormous dimensions, it was designed to cruise at speeds exceeding 2,000 miles per hour. To achieve this incredible performance, the Valkyrie relied on 6 General Electric YJ-93 turbojet engines mounted beneath the rear portion of the aircraft. Together, these engines generated extraordinary thrust, propelling the massive bomber through the sky at speeds that few aircraft have ever achieved. Heat became one of the greatest engineering challenges. At Mach 3, air friction caused temperatures on parts of the aircraft to rise dramatically. Traditional aluminum construction would not survive such conditions. Engineers turned to stainless steel honeycomb panels and titanium components to withstand the extreme heat generated during sustained high-speed flight. Building the aircraft required new manufacturing techniques and materials technology that pushed the aerospace industry forward. The cockpit represented another marvel of engineering. Pilots sat inside a sophisticated environment filled with advanced instrumentation designed to manage one of the most complex aircraft ever built. Flying at Mach 3 required precise control and constant monitoring of systems. Visibility during takeoff and landing was enhanced through a movable nose section that could lower to improve the pilot's view. This feature later became famous on another supersonic aircraft, Concorde, but the Valkyrie had implemented a similar concept years earlier. When the first XB-70 prototype finally took to the skies in September 1964, it represented the culmination of years of research, development, and innovation. Aviation enthusiasts around the world watched with fascination as the futuristic bomber demonstrated its capabilities. The aircraft successfully reached speeds beyond Mach 3 and altitudes exceeding 70,000 feet. These achievements confirmed that the revolutionary design concepts worked in real-world conditions. Watching the Valkyrie in flight was an unforgettable experience. The aircraft appeared elegant despite its immense size. As it accelerated through the sound barrier and continued toward Mach 3, it showcased a level of performance that seemed almost unbelievable. At those speeds, crossing entire states took only minutes. The bomber could theoretically penetrate enemy airspace faster than most defenses could react. Yet while the XB-70 achieved impressive technical success, the strategic landscape was changing rapidly. During the early stages of development, military planners believed that speed and altitude would guarantee survival against enemy defenses. However, advances in missile technology began altering that assumption. Surface-to-air missiles became increasingly capable of reaching high-flying targets. The Soviet Union developed sophisticated air defense systems that reduced the advantages previously enjoyed by high-altitude bombers. At the same time, intercontinental ballistic missiles were becoming a dominant component of nuclear deterrence. Missiles could deliver nuclear warheads across continents in a fraction of the time required by bombers and without risking flight crews. As defense priorities evolved, the justification for an expensive Mach 3 strategic bomber became more difficult to maintain. The Valkyrie program faced growing scrutiny because of its enormous cost. Developing such an advanced aircraft required billions of dollars in research, testing, materials, and manufacturing. While the technology was impressive, military leaders questioned whether the bomber offered sufficient advantages compared to alternative systems. Budget pressures and changing strategic doctrines ultimately led to the cancellation of the B-70 bomber program before it could enter operational service. Although the bomber mission was cancelled, the aircraft itself remained too valuable to abandon completely. The XB-70 became an important research platform for studying supersonic flight. NASA and the U.S. Air Force used the aircraft to gather data that would influence future aerospace projects. Engineers learned valuable lessons about high-speed aerodynamics, structural heating, materials science, and propulsion systems. Much of this knowledge contributed to later aircraft and space programs. One of the most dramatic chapters in the Valkyrie's history occurred on June 8, 1966. During a promotional photo flight involving several aircraft, tragedy struck. The second XB-70 prototype collided with an F-104 starfighter. The smaller aircraft was caught in the Valkyrie's powerful wingtip vortices, causing a catastrophic accident. The collision destroyed the second prototype and resulted in the deaths of several crew members. Images and footage of the accident remain among the most sobering moments in aviation history. The loss deeply affected the aviation community. The accident highlighted both the extraordinary power of the Valkyrie's aerodynamics and the inherent risks associated with flight testing advanced aircraft. Despite the tragedy, the surviving prototype continued its research mission and contributed significant data before the program eventually concluded. As the years passed, the XB-70 Valkyrie earned legendary status among aviation enthusiasts. Many consider it one of the most beautiful aircraft ever designed. Its sleek white finish, dramatic canards, massive delta wing, and futuristic proportions create a visual presence unlike any other airplane. Even modern stealth bombers and advanced fighters struggle to match the sense of awe inspired by the Valkyrie's appearance. The aircraft also symbolizes a unique era of optimism and ambition in aerospace engineering. During the 1950s and 1960s, engineers believed that technology could overcome almost any challenge. The Valkyrie embodied that mindset. Instead of accepting limitations, its designers pursued solutions that pushed beyond existing boundaries. The result was an aircraft decades ahead of its time. Many aviation historians compare the XB-70 to Concorde and the State Route 71 Blackbird because all three aircraft represented the pinnacle of high-speed flight. However, the Valkyrie occupied a category of its own. It combined the size of a strategic bomber with the speed of an interceptor and the technological sophistication of an experimental research aircraft. No other aircraft has ever matched that combination of characteristics. Visitors who see the surviving XB-70 today often find themselves amazed by its scale. Standing beneath the aircraft reveals just how enormous it truly is. Photographs can capture its beauty, but they rarely convey its physical presence. The aircraft dominates the surrounding space, reminding viewers of the incredible vision that produced such a machine. The Valkyrie's legacy extends beyond its technical accomplishments. It serves as a reminder that innovation often involves taking risks and pursuing ideas that seem impossible. While the aircraft never entered operational military service, it succeeded in demonstrating technologies that expanded the boundaries of aerospace engineering. The lessons learned from its development continue to influence modern aircraft design. Looking back, it is easy to wonder what might have happened if circumstances had been different. Could a fleet of operational Valkyries have changed military aviation? Would advances in electronic warfare and tactics have allowed the bomber to remain effective despite missile threats? These questions continue to inspire debate among historians and aviation experts. While definitive answers remain elusive, the discussion itself reflects the aircraft's enduring fascination. Even decades after its final flight, the XB-70 remains a symbol of American engineering excellence. It represents a time when designers dared to imagine an aircraft capable of cruising at Mach 3 while carrying out strategic missions across the globe. Few projects have combined such ambitious goals with such groundbreaking technology. For aviation enthusiasts, the Valkyrie is more than a historical aircraft. It is a masterpiece of design, a testament to human ingenuity, and a powerful